Section 2.2 continued. Here we want to start out with the definition of a standard form of a linear equation. The standard form of a linear equation is in the form of ax plus by equals c, where a, b, and c are real numbers, and a and b are not both 0 at the same time. A and b are going to be coefficients for x and y, and c is a constant. We also want to have a and b to be non-fractions. Next, point-slope form. The point-slope form of an equation of a line is y minus y sub 1 equals m times the quantity of x minus x sub 1, where m is the slope, which we just determined on previous slides, of the linear equation, and also we know that the ordered pair x sub 1, y sub 1 is a point that is on that line. In other words, we'll be able to substitute in for x sub 1 and y sub 1. Let's look at the procedure to put an equation into standard form. 1, we want to copy the problem down. 2, if given a point and slope, put into point-slope form. Then we want to simplify by distributing and combining like terms. If there is a fraction on the x or y term, eliminate the fraction by multiplying by the least common denominator on both sides. Number 5, get the x and y variables on the left side of the equal sign by itself by inverse operation, ordered x, then y, in other words, alphabetical order. And then 6, if the x term is negative, multiply both sides of the equation by -1. So our x term, or a, is positive. Our first example, write in standard form the equation of each line given. 1, the slope m equals a -2. Recall that it is a ratio of rise over run, so we have a denominator of 1. And we have a given point on the line, which we know is x and y. We can call this x sub 1 and y sub 1. We first want to substitute into our point-slope formula, which we know is y minus y1 equals m times x minus x1. We substitute the known values. Y minus y sub 1 is a -2, so minus a -2 equals m, which we know is a -2. Bring down the x, the minus sign, and x sub 1 is 3. Now what we want to do is simplify. Y plus 2 equals, here we can distribute a -2 x plus 6. Get the x's and y's on the same side, so we're going to add by 2x on both sides. That gives me 2x plus y plus 2 equals 6. Subtract by 2 on both sides, and that gives me 2x plus y equals 4. Our a is 2, our b is 1, and our c is 4. No fractions for a and b, and a is also positive. Our next example, we want to do the same thing. Write this given information into standard form. We know our point-slope formula is y minus y1 equals m times x minus x1. Substituting in y minus y1 is 7, m is 3/5, x minus x sub 1 is a -4. Watch the signs with the double negative. Let's simplify. Y minus 7 equals 3/5 x. Double negative is a positive, times a positive is going to give me 12/5. Notice there are fractions in our problem. Let's eliminate the fractions by multiplying both sides by the least common denominator, which is going to be 5. 5 times y is 5y minus 35. Just multiply the numerators. 5 times 3 is 15. 15 divided by 5 is 3x, plus 5 times 12 is going to give me 60. 60 divided by 5 is going to give me 12. Now let's put this in standard form. Subtracting 3x on both sides gives me a -3x plus 5y minus 35 equals 12. Let's get rid of the 35 by adding 35 on both sides. Negative 3x plus 5y. Adding 35 on both sides is going to give me 47. But my a term is negative, and I want that to be positive, so I'll multiply the whole equation by negative 1. Negative times a negative is a positive 3x. Negative times a positive is a minus 5y. And a negative times a positive is a negative 47. And that is my standard solution. A is 3, B is a negative 5, C is a negative 47. Our third example, we have a slope of 2/3 and an ordered pair of a negative 4, 0, letting that be x1, y1. Let's substitute into our point slope formula. Y minus y1 equals m times x minus x1. Bring down the y. Y1 is 0. M is 2/3. X minus x sub 1 is a negative 4. And when I simplify, that gives me y on the left equals 2/3 x. Negative times a negative here is a positive 4. A positive 4 times 2 is going to give me 8/3. Let's get rid of the fractions by multiplying both sides by the least common denominator, which is 3. That gives me 3y equal to 3 times 2 is 6 divided by 3 is 2x plus 3 times 8 is 24 divided by 3, which is going to give me 8. Subtracting 2x on both sides gives me a negative 2x plus 3y equals 8. My a term is negative, so I'm going to multiply both sides or the whole equation by a negative 1. That gives me, when I distribute, negative times a negative is a positive 2x. Negative times a positive is a negative 3y. And a negative times a positive 8 is a negative 8. There's my standard formula. An a is 2, my b is a negative 3, and my c is a negative 8. Our next procedure is to write point slope form of an equation given 2 points. Number 1, we want to copy the points and label of x1, y1, x2, y2. 2, we want to substitute those points into the slope formula, which we have had in the several past slides. Number 3, substitute the first point given from the 2 points and the slope into the point slope formula. Simplify to standard form if asked. So what we want to do is write the point slope form of the equation of a line through each pair of points. We're given 2 points and we know how to label x1, y1, x2, y2. Let's find the slope, and we know that that slope is going to be m equals y2 minus y1 over x2 minus x sub 1. And when we simplify, we're going to get a negative 8 over a negative 3. So my slope is 8/3. We want to substitute our information, knowing our slope equals 8/3, and our first point in our set into the point slope formula. So y minus y1 equals m times x minus x1. That gives me y minus, using the first point given to us, is going to be a minus 4 equals m, which is 8/3. X minus x sub 1, which is a negative 5. Then we simplify. Y minus 4 equals 8/3 x plus 5. At this point, we have put the points into point slope form. If we were asked to put it in the standard form, we'd further simplify and place it in standard form. Next, we want to write these 2 ordered pairs into a point slope form. So the first we want to do is label x1, y1, x2, y2. And we want to substitute that into our slope formula. So we're going to have y2 minus 4 minus y1, which is a negative 7, over x2, which is 9, minus x1, which is also 9. Simplifying, that's going to give me a negative 4 plus 7 is 3 over 0. So my slope is undefined. Therefore, I know I have a vertical line. And I know a line that is vertical on a coordinate plane must only intersect the x-axis. So if I substituted this into my point slope formula, I'd have y minus y1 equals m times x minus x1. Therefore, y minus a negative 7 equals an undefined slope, 3 over 0, which is going to give me, when I substitute in for the rest, x minus x1, which is going to give me 9. But there's not much I can do with this equation because of this undefined slope. So what I have to do is actually take a look at the ordered pairs. And here, I know a vertical line intersects the x-axis. Therefore, I need a value of x. But if I look at the ordered pairs, I can do that because notice both values of x in each ordered pair are the same. Therefore, I must know that x has to equal 9. And that is my equation for the problem. So a lot of times you can save yourself a lot of work if I look at the ordered pairs and determine that either the x values are the same or the y values are the same. Here, I think if I did do that and take a look at that my y values are the same, I would find out that negative 5 and negative 5 is my y. That would be y equals a negative 5. I can go through the procedure as before, finding my slope, y2, negative 5, minus y1, negative 5, over x2, 6, minus x sub 1, 12, gives me 0 over a negative 6. Therefore, my slope is 0. That means I'm going to have a horizontal line. Now, I can substitute in y minus y1 equals m times x minus x1. That gives me y minus a negative 5. M is 0. X minus x1, which is 12. So this gives me y plus 5 equals 0 times anything is 0. And then when I simplify by subtracting 5 on both sides, y equals a negative 5, which is what I started with when I noticed that negative 5 is in both positions for the y in each ordered pair.